Advent of Code, Day 14, 2024, Restroom Redoubt. So I'm going to get a list of X and Y positions and velocities for robots. And they tell us very explicitly somewhere in here that the space we're working in is 101 tiles wide and 103 tiles tall. In the example, we're going to do 11 and 7. And basically, the robots are going to move. They wrap around the edge. So if you go off the right side, you just come back on the left. If you go off the top, you come back on the bottom, and vice versa. And we just need to go 100 seconds and then calculate a safety factor. And the safety factor basically means take out the middle row and the middle column, and then calculate how many robots are in each quadrant, ignoring the ones that are on the lines, and multiply those together, and you get your result. So let's go ahead and take a look. I will do a gen day here for day, not 12, 14. We'll come in here. I better get the example input. Okay, I'll put this here. We'll take a look at the input. It is, looks like 500 lines long. I'll note we have negative velocities. We don't seem to have negative positions. That seems like it. All right, so let's look here. We are going to read in lines. That makes perfect sense to read them in lines, and we will loop over our lines. We do need to handle the width. Let's do that first. So if this.argv, that's how I call it, is equal to input.text, then width comma height is equal to I don't remember what it was. Was it 101? 101 and 103. Else width height is equal to, for our examples, 11.7. All right, then we read in our lines, and we will do a for line in lines. What do we need to do? So we need to parse this, and I'm going to use regex, re, and we will say x, y, dx, dy, and this will be a really cool use of regex. We can do re dot find all. We're just going to say, might have a negative sign. So we put the question mark means 0 or 1, and then we'll have digits. Plus means 1 or more, and that is it. So when we apply that to a line, let's grab a line, that is going to basically find 4 things, which we will then map right into those 4 things. We do need to convert those to numbers, so we will say tuple map int around that. So that's the map will take the int function, apply it to each object in the list, and then that returns it as a generator. So tuple converts it back to a thing that I can assign to 4 things. We can do a print x, y, dx, dy. We can run Python day 20. There we go. And that looks great. Okay. Now we can actually solve all this right now. So we can say x final equals, and this is the cool thing about, we can say x plus dx times 100. And then if we take this all and just do mod width, that will cover all of our wraparounds. It doesn't matter how many times we would have wrapped around, we covered it right there. So we can do the same thing with yf equals y. I don't think I need nearly this many parentheses, but I just like to always be explicit about it. I should make this dx. That would be more useful. Times 100 mod height. And there we go. Now we just need to figure out what quad we're in. So we can do, let's create some quads. Let's call it Q equals, and we'll make a list of zeros, of 4 zeros. And so now we can say if, and I'm going to have to, well, let's see, we'll call this mid H, mid W, mid H is equal to, because I just want to type this out so many times, width divided by 2, height divided by 2. And now we can say if xf is less than mid W and yf is less than mid H, Q0, and 0 is very arbitrary here. I'm just picking something. It doesn't matter at this point. Plus equals 1. L if xf is less than mid W. I wonder if we should do this in 2. Maybe it's slightly less typing. Let's do it like this. If that, there. And we say if yf is greater than mid H. And I can't just do else because I need to leave out the middle. So q1 plus equals 1. And we'll say elif x mid w. If we're greater than mid w. Ooh, what did I hit there? And if this exact same thing right here. I know copying is bad, but let's see. I'm gonna make this 2 and make this 3. Might be done. We'll need import math. Hey, I always hate that you have to import math to get the product. Prod feels like a thing that should just exist, like sum. Q. We might be done. Let's see. 12, I believe, was the example value. It is. Check out here. I'm hoping. Let's see if this is right. Sweet. I'm hoping that this is just now like run for a gazillion years and we've already solved it because we didn't try to step through, we could step through 100 times and step each time and calculate each robot, but let's take a look, or I'm gonna go read it. All right, it was not what I was hoping it was gonna be. Instead, we're gonna look for when the robots organize themselves into a picture of a Christmas tree. I don't really love this problem because I don't like when it's undefined like that. I've actually been off playing for a little bit. I've tried a few different things. I think I found something that works. I've not actually tried to submit it yet, but I've at least I played down several paths that I didn't think didn't work out. I was trying to like cluster things, or I was trying to look for like anyway. What we're going to look for is we're going to play with the safety score. And so what I want to do here, we're going to come back here and we're going to start by doing some refactoring. And we basically did 3 steps in one here. We parsed the input, we moved the robot, and then we calculated the safety score. And I want to break that into pieces to make this more modular so I can do more useful things. So the first thing we're going to do is come up here and we're going to say def safety score. And we're going to take in robots. And those are going to be a list of tuple of int. And that is going to return an int. And we'll take pass for a moment. So a safety score is going to, we'll have to start with the quads. And then we'll say for x comma y in robots. And then we're going to do this. I'll have to, whoops, let's see. Shoot in like that. So for each robot, we get the x and the y. We'll make it the xf and the yf. We're going to calculate all our quads, and then we just return math.prod q. And so that should give us our safety score for a list of robots. So now we need a list of robots. So we need the like initial robots. So we're going to call that like robots, for lack of a better word. In this list, we're just going to do robots.append x, y, dx, dy. Now I've got a list of robots. Now for part 1, we're going to say part 1 robots is equal to another list, and we'll say for x, y, dx, dy in part in robots. So we're going to go over each of our robots. We're going to calculate here, just like we have, the width and height at 100. And then we can say part 1 robots.append xf yf. Now we should be able to come down here and say safety score part 1 robots. And if this works, we can say Python day14 example. We're looking for 12. Beautiful. Input 218 ending in 120. Let's check our score. 218. Yes, so that looks. So we've refactored this entirely. We've done nothing. We've just solved part 1 again. Now what I'm going to do, for part 2, is we're going to look at the safety score over time. So we're going to say, we'll say like, let's see, t equals this, and safety score equals empty. And now we can say for I in range, I don't know, 10,000, 100,000, something. Let's try 10,000, see if it's too big. Now for each step, we're going to say, we're going to need to figure out where the robots are. So snapshot of robots is this. I'm making stuff up at this point, but we can say for x, y, dx, dy in robots. Snap. Oh, I guess we'll say xf. Let me just grab you right here. Boom. Tab you in. Xf is equal to that times I. We're going to get that step. And then we will say snap dot append xf, yf. And so now this little loop is, so for any given time, we're going to loop over the robots, figure out all the robots are, and then we can say t dot and I and safety score dot and safety score snap. And then what we can do is we can plot this. So I'm going to just forget this. It's like import matplotlib.plt, I think it is. Is that right? PyPlot, that's it. That is PLT. And now I'm gonna come down here and I'll say PLT dot plot t.ss and plt dot show. I think that's all we need. So if we run this now, take a second, but hopefully not too long. Cool. So this is our safety scores, and it bounces around, and this is where I stopped. So I was like, oh, there's a safety score right here. In fact, we can, let's see, if we zoom in on this, we keep zooming. 70:55 is the time. Well, I mean, we could try to submit this even without looking. We got, so that's it. We found it. So I wish they just asked us for that. I think it's kind of obnoxious that they do it this way, but like, so we can print out what this looks like. Close you. What did we say it was? 70:55. Go back. 70:55. So we could say when I equals 70:55, when it breaks to 70:56, I believe is like this. And then we can come here and we can say for, what do we have here? We got a list of X's and Y's. So we can say for row in, for X in width. No, we don't. For Y in range height, for X in range width, if X comma Y in snap, print that, else print dot. We're going to need to put an end on this. That end equals like that. Then we print. Once we get through the X's, we're just going to print like that before we loop. And I guess we should comment you, not delete you. And if we do this now, get something kind of cool. That doesn't exactly look like. Oh, there's our Christmas tree. There's a Christmas tree right in the middle there. We got a Christmas tree. I don't know. I don't love it. I think what I could do is go through here and record, put this back to 10,000, record the minimum, and then save that as my answer and show it as part 2. I guess this is the way to do it. But I don't know. I don't like the problem. So I'm gonna call it here. Thanks for hanging out with me today, and I'll talk to you next time tomorrow. Bye.